This is my project titled Motion Analytics for Sportsperson. Introduction. Gait Analytics. Gait analysis is essential in healthcare, diagnosing movement disorders and prevent posture related disorders by suggesting improvements. Sports science, helping athletes improve running technique and prevent injuries. Rehabilitation, monitoring recovery progress for injured patients. Elderly care, detecting mobility issues in senior citizens. And general posture correction and gait improvement. Objectives: process human gait parameters from video input, offer suggestions for gait improvement, understand the trend of gait parameters with respect to speed. PEAS, performance measure, accuracy in gait predictions and video processing. Environment: indoor, actuators, treadmill, sensors, camera for video input. Workflow: using input videos of person walking on treadmill at various speeds, extract key points from videos, calculate gait parameters and train the model, generate personalized solutions based on standard values, display gait parameters, personalized suggestions and also graphs for joint angles. The model is retrained for each input video and updated, developed a UI for taking input video and displaying gait parameters. Tools and technologies used. The project was implemented in Python using following libraries: MediaPipe for key point extraction, OpenCV for image processing and video overlay, Matplotlib for plotting joint angle graphs and recognizing gait cycles, Random Forest Regressor for model training. Here is my analysis for 3 km per hour walking speed. This is the input video. This is the output video. As you can see, I have also plotted graphs for knee, hip and ankle angle. Next is my analysis for 4 km per hour walking speed. This is the input video and this is the output video. Next is my analysis for 5 km per hour output. This is the input video. This is the output video. As you can see from the parameters listed here, we can see that all the parameters are increasing with speed. From the graphs, you can see that the increasing trend is not necessarily linear. This could also be because of the data set used for analysis was very small. Research paper. To validate my analysis, I referred to a research paper titled Effects of Walking Speed on Gait Biomechanics in Healthy Participants, a systematic review and meta-analysis published on NIH website by authors Claudian Arakaki Fukuchi, Reginaldo Kisho Fukuchi and Marcos Duatre. Walking speed influences gait parameters. The study found that variations in walking speed significantly affect gait parameters, joint kinematics, and joint kinetics. Specifically, as walking speed increases, there is a corresponding increase in these gait parameters. Conversely, slower speeds result in decreased amplitudes. Consistency across age groups. The review included data from 587 healthy individuals across different age groups: children, young adults, and older adults. The influence of walking speed on gait parameters was consistent across these groups, indicating that speed-related changes in gait parameters are not specific to age. Conclusion: given that the walking speed alters key gait parameters, the speed emphasizes the importance of accounting for speed variations when analyzing gait patterns. This is particularly crucial when comparing pathological gait to normal gait, as differences in speed could confound the assessment of gait abnormalities. This is the working video of the user interface that I have developed for this project. Here, as you can see, I have to give the input video file, enter the speed at which the person is walking in the video, and then I click on analyze. Here, as you can see, there is the output. On the left side, you can see key optimal values of gait parameters. On the right side, there is an output video with values of the gait parameters calculated overlaid on the video. Apart from that, there are also graphs for knee angle, hip angle and ankle angle. There were also suggestions given for improvement of if there were any parameters that were out of range. Here is an example of how the graphs were plotted. From the lines, orange lines here on the graph, you can see that I use them to calculate the number of gait cycles in the video. Also, I use the knee angle graph for this because it gave the most accurate values. I use the peaks of the graph to calculate the gait cycles. Final results. Successfully extracted key gait parameters, cadence, knee angle, hip angle, ankle angle, stride length and gait cycles from video data. From the graphs we can see that the speed increases, all the parameters increase, but the slope is not constant. Generated suggestions for gait improvement and developed a UI for gait analysis that is easy to use. My learnings: accurate key point detection to calculate various gait parameters, how to read and understand a research paper, variations in gait parameters at different walking speeds, get knowledge of potential real world application of gait analysis in medicine and sports. Thank you.